Okay. In this video, we'll be, as I told you in the previous video, we'll be now finding the equations for the six important parameters, that is VP, gamma, alpha, beta, lambda, and eta, intrinsic impedance. Okay. The first one is going to be the phase velocity. So as you can see, it is nothing but the velocity with which the wave is traveling or propagating. And we can either write it as VP, which stands for phase velocity, or just as V, okay, velocity. And it is nothing but distance by time. We know that the wave is traveling in z direction, so it is dz by dt. The distance traveled by it is in z direction, so dz by dt. Or another way I can write it is omega by beta. And in the previous video, if you remember, the beta value was found out to be omega root mu epsilon. So if I substitute that, I will get the velocity equation as 1 by root mu into epsilon. Okay, so this mu will be combination of mu naught and mu r. Epsilon will be combination of epsilon naught and epsilon r. So this equation is very important. Phase velocity is 1 by root of mu epsilon. And for free space, mu will become mu naught, epsilon becomes epsilon naught. And if I substitute these values, in free space, we find out that the velocity of the wave is same as the velocity of the light. Okay, so for free space, the velocity is 3 into 10 power 8 meter per second, which is same as velocity of light c, right? So this two things very important. The general equation for V is 1 by root of mu epsilon, and for free space, it is equal to 3 into 10 power 8 meter per second, that is velocity of light. Okay, this is the first parameter. Now going to the second one, second parameter is eta. Okay, which is called as impedance. It is an impedance whose unit is ohms. Okay, and this is called as intrinsic impedance. We can find out eta by knowing what is the relation between E and H in free space. Okay, if at all they ask you to derive the equation for eta, you have to start from here. You have to get the relation between E and H. From there, you will be able to find out what is the equation for impedance, intrinsic impedance. Okay, so for that, we are going to start off with the Maxwell's equation. Del cross E is equal to minus dou B by dou T, or del cross E equal. Since I want to know the relation between E and H, I am writing B in terms of H. So B is mu into H. Okay, so del cross E is equal to minus mu dou H by dou T. This is nothing but curl operation, right? Del cross E is curl operation, and we are taking XYZ Cartesian system. So the curl in Cartesian system is written in this format. This is a matrix for curl. On the other side, we are expanding H in vector form. So it can be written as Hx Ax plus Hy Ay plus Hz Az. It's a vector form of in Cartesian system for H. Okay. Now next thing is, out of all the three, what you have taken here, dou by dou x, dou by dou y, dou by dou z, only the z component exists because your total wave is traveling only in z direction. So this x and y will be removed. So your matrix will change to 0, 0, dou by dou z. Second thing is, I am assuming that the E is existing only in x direction. So y and z of E will be 0. Okay, so two things you have to change in the matrix, and this will be the new matrix now. On the other side, if E is in x direction and if the total wave is traveling in z direction, then H should be only in y direction. So x and z component of H will be removed and only this much is left for the H. Okay, so this is the final matrix you have. Take the determinant of the matrix, you will end up with this. AY gets cancelled on both the sides and you have only this much now. Dou Ex by dou Z is equal to minus mu dou Hy by dou T. Now, the next thing what they're doing is Ex. In place of Ex, they're substituting the equation which they got from the previous derivation. That is, we saw in the previous video, right? Uniform plane wave in free space. We found out the equation for Ex there. That is substituted here on the left hand side. So differentiate with respect to Z. You differentiate this equation with respect to Z and just pause the video and check what the differentiation result is going to be. Okay. So after differentiation, see, differentiation of cos is, the differentiation of cos is minus sine, and again you have minus beta z, right? Differentiation of cos omega t minus beta z is minus sin omega t minus beta z into minus beta. So minus into minus becomes plus here. On the other side, differentiation of cos omega t plus beta z is again minus sin omega t plus beta z into plus beta. So you got minus here. Okay, just do the differentiation. Then you put it in this equation like this, right? And they've taken this dou hy by dou t to one side and all remaining terms to the other side. And to get the equation for hy, you have to integrate. To remove this differentiation, integrate on both the sides. Okay, and on integration, you just do the integration yourself. Just pause the video and check the steps. You will know how the integration is done. And once you reach this step, next what they have done is they're comparing. This part of the equation can be written as h plus. And this is also the magnitude, right? This can be written as h minus. Right? From there, I'm going to get the relation between E and H. So H plus is nothing but beta by omega mu EM plus. HM minus is minus beta by omega mu EM minus. Now, if I have to take the ratio of this, what they've done here is they've kept EM plus as it is. Beta is taken to the denominator, so it becomes omega mu by beta. And we know beta is nothing but omega root mu epsilon. So omega gets cancelled here. You get mu by root of mu epsilon. Can I write it as mu square by mu epsilon whole root? It's the same as writing mu by root mu epsilon, right? So then what happens? This one get cancelled. So I can write it as mu by epsilon. That is what you got here, right? So now finally what I can say is if I take the ratio of E and H, if I take EM plus by HM plus, or if I have to write in terms of negative, it is minus EM minus by HM minus, which is nothing but equal to root of mu by epsilon. This is called as intrinsic impedance. The ratio of E by H is called as intrinsic impedance. If I'm taking positive values, it is E plus by H plus. If I have negative values, it will be minus E minus by H minus. And that is nothing but root of mu by epsilon. So remember this formula, eta is root of mu by epsilon. Also, eta is ratio of E by H. Positive values means positive sign. If it is negative values, it will be negative sign, minus. Based on the data given in the problem, you have to choose one of these equations to find intrinsic impedance. Okay, this is second parameter which is very important. They may ask you the derivation or they may just ask you the problems based on this. Okay, so this is the second one, intrinsic impedance, eta. And again, in free space, mu will be mu naught, epsilon is epsilon naught. If I substitute the values, I will get the answer as 377. This is the fixed value of impedance for free space. Okay. Either 377 ohms or 120 into 5 ohms. Both will give you same answer. This also gives you 377 only. Okay. So for free space, the value of eta is 377 or 125. Right. So that was the second parameter. Now going to the third one, propagation constant gamma. So here is a derivation for that. So propagation constant derivation is done with the help of this del square E equation again, del cross E. That is your Maxwell's equation. So del cross E is equal to minus mu dou H by dou T. Take curl on both the sides. Okay. And del cross H equation, that is sigma into E less epsilon dou E by dou T. So once you take del cross H, in place of del cross H, you are substituting this. That is how we got this equation. Okay. And then in place of dou by dou T, they are substituting j omega. And this is the equation you get. And if I just take j omega mu common from both the terms, this is the equation you're going to get. And this is called as phasor form of the wave equation. Okay. So if you write in terms of j omega, it is called as phasor form of wave equation. Please remember these two equations, okay, del square E and del square H. J omega mu, j omega mu. Sigma plus j omega epsilon, sigma plus j omega epsilon. Only thing that changes is E H. Okay, so this is very important. It is written as j omega mu into sigma plus j omega epsilon. And now they are comparing this with another equation. del square E is equal to gamma square into E. So compare these two. In place of gamma square, you have this term. Okay, so that is your propagation constant. If gamma square is equal to this, then gamma will be square root of this value, right? That is what you're getting. So this is the equation you have for propagation constant, square root of j omega mu into sigma plus j omega epsilon. And the propagation constant is said to be a complex quantity where it has both real and imaginary part, and it is written as alpha plus j beta, where alpha stands for attenuation constant, beta stands for phase constant. Okay, so alpha is attenuation constant whose unit is given as Nepper per meter. Beta is phase constant whose unit is radians per meter. Right? So in the next page, I've given you the direct equations for alpha and beta. These are the general equations of finding out attenuation constant and phase constant. You need to remember these formulas. In the next video, when I start problems, there is one problem where they are asking you to prove that these are the equations. So there's a derivation given for this. I'll explain the derivation there. Okay. For problems, you may need to remember these equations. Right. So this is the equation for alpha. This is the equation for beta. If you compare these two, no, there is only one change between these two. For alpha, you have -1. For beta, you have +1. Remaining terms are same. Remaining, there is no change in any other term. Only -1 +1 is what changes for alpha and beta. Okay, if you remember one, the other one you just change the sign for the last term. Right? So that's about alpha and beta. And for free space, the attenuation constant is 0 and phase constant is given as omega root mu naught epsilon naught. Okay, so these two equations, these two is very important. This is the free space equation, which is very important. Okay, the next one, the last parameter, that is wavelength. So wavelength is nothing but it is a distance which the wave is supposed to travel so that it keeps on repeating itself. See, if I take a sinusoidal signal, we know that the repetition, one cycle is going to be for 2 pi radians, right? So it is repeating after every 2 pi radians. So wavelength is nothing but the distance that a wave travels before it repeats itself. Okay, so it is given by 2 pi by beta. This is a very important formula for lambda, 2 pi by beta. Okay, another formula for lambda is, the wavelength is velocity by frequency. Okay, velocity by frequency. So two formulas are there, either 2 pi by beta or v by f. These two are very important. Based on what is mentioned in the question, you can use any one of this equation. Okay, and if it is free space, if for free space I told velocity of the wave is same as velocity of light, so lambda becomes c by f, 3 into 10 power 8 meter per second by frequency. Okay, so these are the 6 parameters. It is summarized here. Okay, general equations for these 6 parameters. Velocity, which is 1 by root mu epsilon or omega by beta, or frequency into lambda. Propagation constant gamma, which is alpha plus j beta, which is root of j omega mu into sigma plus j omega epsilon. Unit is per meter. Attenuation constant alpha, whose formula is given here, Nepper per meter. Phase constant beta, radian per meter. Intrinsic impedance eta, which is root of j omega mu by sigma plus j omega epsilon, or root of mu by epsilon for free space. For free space, sigma is 0, so this gets cancelled. J omega gets cancelled, so you'll be having root of mu by epsilon. Unit is ohms. Last is wavelength, which is 2 pi by beta or v by f. Okay, so these equations, general equations, are very important because you have problems based on this. Right, so 6 parameters. Most of the problems they have asked to calculate these 6 parameters only for different mediums. Okay, it can be free space, it can be dielectric, or it can be a conductor. So these 6 equations you need to know, very important. Similarly, you have table for remaining 2 medium. Okay, so this is general medium equation. Here you have free space. In free space, the main thing you need to know is, one is conductivity is 0 and constant is 0. Attenuation constant is 0. Okay. So here you have velocity is equal to 1 by root mu naught epsilon naught, which is equal to 3 into 10 power 8 for free space. Propagation constant will be only j beta because attenuation constant alpha is 0 for free space. Phase constant beta will become omega root mu naught epsilon naught. Intrinsic impedance will be 377 fixed for free space. Wavelength will become c by f, that is velocity of light by frequency. So this set of equation is very important for solving problems under free space. Okay, so just remember this table. Right? So I'll stop here for this video. In the next video, I will solve problems based on whatever equations we have seen for free space wave propagation. Right? Thank you.